Okay, this is the third law portion of the basics video, and I actually introduced started this whole unit with this quick video, and we'll watch a little bit of it. Let's see if it'll come up. Oh, here it comes. Alright, this is called the T-Rex rifle. Oh, error occurred. So we're not going to watch the video, but it's something a lot of us have seen before. A person shoots a gun. We'll call that a big rifle. And the person's holding the gun. But when they fire, boom, the bullet goes forward, the person comes back. So here's your bullet, goes forward, but it also pushes the person back. And why? So that's kind of our topic for the last portion of this unit. Basic idea will be this today. Define Newton's third law and provide examples. This will be kind of the proficient and the advanced portion. Alright, first thing. Action-reaction is a new term, and so is equilibrium. The normal force we'll get to on the next video. We're going to focus on these ones today. Alright, so first thing, Newton's third law. Write down the definitions as they go. I go fast on these podcast type videos because, well, you can always just pause the video or rewind. The definition of Newton's third law: for every action there's an equal and opposite reaction. And the math part, the formula looks like this. Force A on B is equal to the negative force B on A. So just remember, opposite, it's really talking about direction. And that's kind of what this negative means. It's signifying direction. So that's kind of a funky picture, a kind of funky version of it. So let's draw a picture. Right underneath your notes, draw this picture. We've got a fist hitting the wall. And we'll give that bam. Do that in blue. Okay, so we have first, right here, action. Force, fist on wall. But anybody who's ever really punched a wall knows that there is also a reaction where it kind of hurts. This would be the force of, and we'll do it in a similar color, force of wall on fist. So this is our action-reaction, and this would be the negative sign over here. It's the opposite direction. This is true of lots of examples. So right now on page 20, I want you to draw, this is 21 by the way, sorry guys. On page 20, I want you to draw 3 of these. 3 force interactions where you have the arrows, they're in opposite directions, list the description on one side, and the reaction description on the other. So pictures. Sports are good at this, like football or golf or baseball or soccer. Throwing, people getting hit with things, anything you want. So you can pause the video and do those. I'm going on to the next topic. The next page, here's my examples. Teeth, push down on sandwich, sandwich, push up on teeth. When you're running, you're actually pushing backwards on the planet, and the planet is pushing forward on you. When you're sitting in the chair, we've talked about this one a lot. You push down on chair, and the chair pushes up on your body. Action, reaction. Next thing, equilibrium. Here's your definition. When forces are balanced and an object is stationary. So let's do this example. Okay, we've got a bar. Write the definition and then draw this example. We have got some rope. And we have got bam, bam. And let's make, okay, so we've got a person, and we'll make it a zombie. Brains. Okay, we've got a person, and we're going to say it's in equilibrium. Forces are balanced, and the object is stationary. So he's just hanging here. 100 newtons. The question is, how much force does each rope have to pull up with to keep the zombie in equilibrium? And if it's pulling down, we know the total up is 100. So each rope must be pulling up with 50. And now we have balanced forces. The person is equilibrium. Everything's balanced. There we go. Very nice. Next topic. This is a basic example. Okay. Here's all I want you to write. Basic example. Draw this picture. Student pushing on a rock. We know the student's pushing with 20 newtons. Instead of writing all of this, you can just draw this picture but bigger. And then the question. Force rock on student. Force rock on student. Question, how much is it? Well, this is only true if the student is in equilibrium. And we have, bam, the rock must be pushing up with the exact same amount this way. So the answer is 20 newtons. This is, again, a basic example. It's not terribly difficult, but here's what I want you to notice. What happens if the kid pushes harder? The rock pushes back stronger and stronger. If the kid pushes less, the rock pushes back less and less. More, less, more, less, right? So the force of an object pushing back changes by how hard it's pushing. And so that is the end of the basic section. We'll move on to Proficient Advanced on the next video.